Hello, this is Dr. Amudapriya, Associate Professor, EEE, Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control, and in this lecture we will be discussing about the economic dispatch problem and the characteristics of the thermal power plant. While considering the economic operation of a power system has several power plants, and each power plant has several generating units. At any point of time, a total load in the system should be met by the generating units in different power plants. Economic dispatch control will determine the power output of each power plant and power output of each generating units within a power plant, which will maximize the overall cost of the fuel needed to serve the system load. The factors considered by the load dispatcher when to interchange the energy from one station to the another station, it will decide how much energy has to be interchanged, what is the cost of supplying of energy to the interconnection, and what is the cost of received energy from the interconnection. The other factors which may be affecting the economy of operation are the varying fuel cost, labor cost, and weather conditions, normal and emergency equipment rating, the reserve requirements, voltage limitations, and the characteristics of prime movers, transmission losses, etc. Next, while considering the main economic factor in the power system operation, it is the cost of generating real power. So what is the main factor which is going to control over it is nothing but the load allocation between various generating units. This will lead to the total cost. Interconnected power system is more reliable and is convenient to operate, and it will offer economical operating cost. For example, for the purpose of economy interchange, it is necessary to consider not only the incremental fuel cost, but also the incremental transmission loss has to be considered for optimum economy. So the economic system operation is necessary because in many cases economic factors and the availability of the primary essentials like the resources availability, this will indicate whether a new generating plant has to be located at a greater distance from the load centers or not. The power systems are an interconnection for the purpose of economy interchange and reduction of the reserve capacity. In a number of areas of the country, the cost of fuel is rapidly increasing. So, how we are going to state the economic dispatch problem is, the complexity of interconnections and the size of the areas of electric power system that can be controlled in a coordinated way is rapidly increasing. This entails the optimum allocation of the outputs of large number of generators. When a generator is getting into action, it will share the load at a given interval time. That is, this is the problem of unit commitment. So once unit commitment problem has been solved, it becomes a problem of optimum allocation of available generators in order to meet the forecasted load demand for that particular period. At a modern energy management center with a highly qualified optimization techniques, they determine not only the optimal outputs of the participating generators, but also the optimal settings of various controlling devices like tap settings of the on-load tap changers, outputs of VAR compensating devices, the desired settings of phase shifters, etc. So, while considering the input and output characteristics of thermal power plant as an example in this case, let us analyze the economic operation of the thermal unit with the input-output modeling characteristics. Right. For this function, let us consider a single unit consisting of a boiler, a turbine, and a generator. This unit, so the diagram is given below. This is the thing. In this function, the unit has to supply the power not only to the load connected to the power system, but also to the local needs for the auxiliaries in the station, which may vary from 2% to 5%. The power requirements for the station auxiliaries are necessary to drive boiler feed pumps, fans, and then condenser, then circulating water pumps, etc., which are present in the system. So the total input to the thermal unit that could be, for example, if it is British thermal unit per hour or CAL per hour in terms of the heat calories per hour in terms of heat supplied or rupees in power in terms of cost of fuel. You can consider any of the units. But the total output of the unit at the generator bus will be either kilowatt or megawatt. So in this case, we can see the fuel input to the boiler is considered. Not only here it is simply driven as boiler, but all the boiler components has to be considered into action. So its respective transfer functions may be considered for the analysis purpose, and from which the steam is being sent to the turbine, and then the turbine with the shaft of generator. This can be considered as a single system where the mechanical power is getting converted into electrical power. So its respective, the turbine's transfer function and the generator's transfer function together, when analyzing as a closed loop system, automatic control of the boiler's fuel input, which is overcoming the disturbances, will always provide a better optimal output.